Our next question is from GATE 2014, Thermodynamics for 2 marks. Actually, we have 2 questions here. We will solve 2 questions, each for 2 marks. First, which one of the following is correct for an ideal gas in a closed? Let's start with the solution. You can see here. First, we will start with this equation: d is equal to TdS minus PdV. Actually, we need to remember 4 equations. If you want, you can remember, or otherwise, if you know that what is the first law of thermodynamics, then you know that du is equal to q minus w. From this we can, since q is equal to TdS and w is equal to PdV, from this we can say du is equal to TdS minus PdV. Now we will see here option A, del u over del v at constant s. If del u over del v at constant s, del u over del v at constant entropy, then this term will be 0 and it will be equals to minus p, right? It will be minus p. Again, if we need to calculate del u over del s at constant volume, this term will be 0, it will be equals to t, minus p and t. If you put the value minus p here, minus pv is equal to nRT, that will not satisfy the ideal gas equation, since we know that ideal gas equation is pv is equal to nRT, not minus pv is equal to nRT. So option A is wrong. Next, we will check for enthalpy. For enthalpy, it is dH is equal to TdS plus VdP. It is also can be derived from these equations, since you know that H is equal to, what is the H? H is equal to U plus PV, and if you want to write it as in differential form, it will be dH is equal to du plus PdU plus VdP, and if you put du is equal to TdS minus PdV, you will get ultimately TdS plus VdP, right? Del H over del P at constant entropy, it will be V, since it will be 0 at constant entropy, and del H over del S at constant pressure, it will be equals to T, since it will be 0, right? Now we will put these 2 values in our second option. From this we will see del H over del P. You can see here we are getting del H over del P is equal to V, and it will be minus, again it will be minus PV is equal to nRT. So this option also wrong. So next we will check this option, option C, and del U over del V at constant entropy we have already calculated as P, and we will check del H over del S at constant pressure, it will be T. This equation, del H over del S at constant pressure is T, right? From this we get PV is equal to nRT. This equation is satisfied, so on option C is correct. Option C is correct. If you want to check it further, you can check. This will be wrong, right? Option C is correct. Our next question, question number 51. Consider a binary liquid mixture at equilibrium with its vapor at 25 degrees centigrade. Antoine equation for this system is given as log base 10p. This, right? We have Antoine constants, and vapor phase is assumed to be ideal. Remember this. And the activity coefficient for non-ideal liquid phase are given as this ln gamma 1, ln gamma 2. If the mole fraction of component 1 in liquid phase is 0.11, then the mole fraction of the component 1 in vapor phase is. Let's start with the solutions here. First, log base 10, we have given this equation. First we need to we will put all the values, and we will calculate the vapor pressure at T is equal to 25 degrees centigrade, right? We will get P1 set is equal to 179.84 torr, and P2 set will be 43.36 torr, since they are given the pressure is in torr, right? After putting the values for component 1 and component 2, you just need to put the values and you will get the answer, P1 set and P2 set. These are the vapor pressures for component 1 and 2 respectively, right? Next, and also they have given the equation for gamma 1, gamma 2, and we have given the value of x1. X1 is equal to 0.11. X1 is 0.11. Then you know that x1 plus x2 will be 1. So x2 will be 0.89. We will put all the values. From this we will calculate gamma 1 and gamma 2. Gamma 1 is 4.627 and gamma 2 is 1.0274. And total pressure will be calculated as P is equal to x1 gamma 1 P1 set plus x2 gamma 2 P2 set, since it is a non-ideal mixture, right? So x1 we know, x2 we know, gamma 1 we know, gamma 2 we know, P1 set we know. From this we get P is equal to 131.16 torr after putting all the values. Now we know that the vapor phase is the ideal mixture. So we can say partial pressure by the Dalton's law, it will be equals to y1 into p. From the Raoult's law, from the modified Raoult's law, partial pressure will be given as x1 gamma 1 p1 set. So we will equate these two equations. Now we are getting y1 p is equal to x1 gamma 1 p1 set, right? We will put all the values. From this we will get y1 is equal to 0.69. This is the final answer, right? So thank you. Please make sure to like, share and subscribe my channel. Thank you.